Hello everyone. In this video we're going to talk more concretely about confidence intervals and specifically a confidence interval for the population proportion P. All right? And so we're going to start very general and then add in more symbols until we get down to the actual formula that you'll be working with in class. Okay? So the general form of any confidence interval that we're going to work with in this class looks like this, which is what we ended the last video on. A point estimate plus or minus some margin of error. Okay, so if we're talking about the example that I used in the last video, what's the average number of fries in a large order of fries at McDonald's? Okay, certainly there's your best guess about how many of them are. There are maybe 100. Okay, 100 fries in a large. I think that may be actually too much, but who knows? We'll start with 100. Okay, as my best guess, and then I have in my mind how much error there is between each time I get a large fry. So I know that they don't vary more than 5 either way. And so to give a person an accurate description about the mean, I might add and subtract 5 from 100. And so what I tell the person is, well, there's probably around 95 to 105 fries in a large fry every time. And that margin of error represents the uncertainty about the point estimate. Okay, I know the point estimate is my best guess, but it's probably off by a little bit. How much it's off by is represented in that margin of error. Okay, so some more things or some more symbols that we need to know in order to do the confidence interval is one is P, okay, the population proportion, great, and then its counterpart is the point estimator. Okay, that point estimate up there, p hat, which is the sample proportion. Okay, so we have p and p hat, and then how do I get at that sampling distribution, or how do I know how far to stretch it out? Stretch the point estimate out to get the interval estimate. It all depends on how p hat behaves. Okay, how much it varies from sample to sample. And so, is there any way that I can describe p hat or know how much it varies from sample to sample? And your answer should be, of course, yes, there is. The sampling distribution of p hat describes how p hat behaves. And which in behaves, I mean how spread out p hat is, okay? Or the distribution of possible p hats. And so we get our information that we knew last time from lesson 6. The sampling distribution of p hat is this. It's a normal distribution with a mean of p, standard deviation of the square root of p times 1 minus p divided by n. Okay, great. This is how p hat behaves, and it's going to inform us about what the margin of error should be. Okay, and of course, the above is only true that sampling distribution if those conditions are met. So we always need to keep that in mind, of course. Okay, so let's dig down further and talk about this margin of error. Okay, and I kept the sampling distribution up here in the top right just so you have that as reference. Okay, because we're going to use it in a second. The margin of error is made up of 2 parts. The first part is called the standard error. Okay, and I'm going to call standard error SE. And you might think, well, the standard error looks a lot like standard deviation. Okay, and you'd be right. Okay, they are almost the same thing. The standard error is the standard deviation of the point estimator. Okay, and so in the last slide I said the point estimator, which is what I mean by point estimator, is the thing that we use to get the point estimate. Okay, and so what we're going to use as our best guess for the population proportion is going to be its sample counterpart, the sample proportion. So so the standard error is the standard deviation of p hat. And so I have to look at the sampling distribution of p hat. And we'll get to that in a second. And then the second thing, so hopefully that all made sense sort of, and you're not too lost, okay? But I understand that's a lot. And we'll go through this all very carefully to make sure that you don't get too confused, okay? So there's the standard error that describes how p hat varies, okay? Because that's part of it. And then the other part of a confidence interval is, of course, how confident you are about the interval, okay? Sort of. So a confidence factor is what I'm going to call it. It takes into account the confidence level and the distribution of the point estimator. Okay, so I now have a new formulation of the interval. So before it was point estimate plus or minus margin of error. Now I've got a new one, point estimate plus or minus some confidence factor times the standard error. So I split up margin of error into two parts, confidence factor and standard error. So it turns out that a point estimate, that p hat, okay, specifically for us, p hat is normally distributed, and so it follows the picture that I have down here, which is the empirical rule, okay, which is showing the empirical rule. The empirical rule says for bell-shaped distributions, and the normal distribution is bell-shaped, that 68% of the observations lie between plus or minus 1 standard deviation. Between 2, it's about 95, and between 3, it's all or nearly all. Okay. We're going to use this empirical rule kind of information down here to find out how much we should stretch the interval by to get our interval estimate, to get our confidence interval. Okay, and so each confidence interval that we make has some confidence associated with it. Okay, I might ask you to make a 90% confidence interval, or a 95% confidence interval, or maybe a 99% confidence interval. And so based on that level of confidence, that's how far I need to stretch out. It takes into account how far I need to stretch out my interval. Okay. So I've got some new terminology that we're building on here. The confidence factor I'm going to call z with a subscript of alpha divided by 2. Okay, z with a subscript of alpha divided by 2. It's going to help me find the confidence factor, right? And so you may notice that I've not only defined that whole thing, but I've also said something about this Greek letter alpha. Alpha is equal to 1 minus the confidence level, which we'll talk about in a second. Okay, so the confidence level is how confident I am, and we'll talk about what confidence even means. Okay, but if it's a 95% confidence interval, alpha would be 1 minus 0.95. Okay, so there's the example. If I'm constructing a 95% confidence interval, which you'll see in a second, then alpha is equal to 1 minus 0.95. Okay, great. So why am I going through all this weird math that I'm doing here? It's going to help me find the confidence factor, which of course, which is part of the formula for a confidence interval for P. So I'm doing this for a reason. So just bear with me. So I have here as a picture a normal distribution. Okay, a normal distribution, and I'm trying to find that number, the confidence factor, to match my confidence level. Okay, and so how we do that is you visualize the normal distribution and you say that whatever percent I want in between, sorry, that's my dog again, whatever percent confidence interval that I want, that's the area under the curve of the normal distribution that I also want. Okay? So if I have a 95% confidence interval, then I want to find the points here and here such that 95% is in the middle. Okay? And so then if 95% is in the middle, then I have to find out what's on the endpoints. Okay, so we'll go to this just in a second. Okay, so this z sub alpha over 2 is the point here such that alpha over 2 of the area of this normal curve lies to the right of it. Okay, and so we know how to do this from lesson 4. Okay, we know how to find this number using the normal calculator from lesson 4, and so we're going to do that. Okay, so for instance, if I want a 95% confidence interval for p, and we'll find out what this means. Okay, but just for the moment, take it without question. 95% confidence interval for p, that means I want to find the points down here, which I've already labeled them, okay, but we'll see in a second, such that 95% of the distribution is in the middle, okay, of this normal curve that's defined by this p up here, right? 95% in the middle. And then, I'm sorry, I was incorrect in my just statement. It's not defined by this. It's actually the standard normal distribution that we did, that we used in lesson 4. Okay, I want to find the point here. Okay, and then equally the point down here, such that 95% is in the middle, and then 2.5% is on each side. You may ask, where did I find 2.5%? I know that the total area under the curve has to be 1. Okay? It has to be 1. So if 95% is here, then 5% is on the outside. And I also know from the normal distribution that this is symmetric, so the same amount needs to be on this side as is this side. So I divide 5 by 2 and I get 2.5. So 2.5% lies over here, 2.5% lies over here. Okay, and so to get this, you would go to StatCrunch. Okay, again, StatCrunch is not working for me at this time. So you would go to StatCrunch, go to the normal calculator, have a mean of 0, standard deviation of 1. Okay, and then you'd have the greater than or equal sign in the probability statement, and the probability would equal 0.025. Okay, then you'd click compute, and you'd get that the number inside the probability statement should be 1.96. Okay, so that's how I get this number. This number is the confidence level that I need for a 95% confidence interval. Now, here's a your turn. Okay, so we saw that for a 95% confidence interval, that number that we need, that confidence factor, was 1.96. There are two other very common confidence levels, 99 and 90. I want you to find the confidence factor for each of them. Okay, so that's just what I did on the last slide. Okay, but instead of 95% in the middle, I want you to try 99 and 90. Okay, and so that's where I'll stop here. I'll see you next time.